So welcome, everybody. And thank you for staying until the last. This is the last day of build. And today we have a really fun session for you. This is deploying complex open source workloads on Azure. And because this is an open source session, we did the session in the open source way. And you can see we have 4 speakers on the stage, and many of us haven't met until yesterday. And actually, 2 of the guys are just introducing themselves on the stage, which is really interesting. So we have a common goal. Our goal, 4 of us, we want to introduce open source on Azure. We want to explain to you how we bring open source workloads on Azure and how we make them thrive on the Azure platform. And we separate our work into small pieces. Essentially, each of us will come from different angles. We bring in our own experience, and we'll introduce what we've done with our customers and partners. And we hope to show some of them to you today. We have, I think, 6 demos and a lot of content. So let's get started. But before we go, let's just do a round of introduction. So I'm Haishi. I'm a technical evangelist for Microsoft. And why don't you go?
Hi, I'm James Baker. I'm Principal SD at Microsoft, but in the technical evangelism group, focused on the open source, large, big data projects.
I'm Mahesh. I'm a program manager in the Azure Compute team, and I work on virtual machines, and I've been working on that for the last 2 years.
Brian Benz. I work for Microsoft Open Technologies, and I specialize in working with open source on Azure and devices. Technical evangelist is my title. And specifically, I've been working lately with Java and our partnerships with IBM and Oracle and a few others.
Let me get a clicker. All right, let's get started. Oh, it works. So our agenda today is actually really easy. We have 3 parts. The first one is to explain how Microsoft loves open source. Then we'll explain why you want to use open source on Azure. Then we'll go through some of the sample scenarios. But open source is a such large topic. So what we will be covering here is only a very small set of the open source community. So if some of the framework or technologies we don't cover here, don't feel bad, because we can only know that much. To explain how Azure loves open source, I think the best way to prove this is to just review what's happened in the past year, more or less in the past 12 months. And in case you don't know, about 20% of virtual machines on Azure are indeed Linux. So Azure is not about .NET only. It's not about Windows only. We're running Linux. We're running other programming languages. And as a matter of fact, we just announced the HD Insight. That's our service. Now runs on Linux as well. And if you're following Microsoft is open sourcing its core technology. Essentially, the .NET framework is going open source. Now you have the core CRR on open source. And our Mono project is taking the core CRR code back to the Mono as well. And ASP.NET is broken from the IIS. You don't have to host ASP.NET website on IIS anymore. We adopted this open standard, which allows us to break the web application from the web server, which means you can host your ASP.NET in your custom process. You can host your ASP.NET in the console application if you want. And with Mono and Core CRR in the future, you can run ASP.NET on Linux in Docker container. That's all possible. Actually, there are already samples today out there that we can run ASP.NET website on a Docker container. And the open source is also changing how Microsoft is delivering our own services. And instead of trying to build everything from ground up, we are looking out at the market. We look at the most popular and the most proven open source technologies. And then we put wrappers around them. We provide value-added services. We manage the resources for you. We gave you the service level agreement. And we put like monitoring, billing support, all those value-added services. But underneath, there are open source technologies. One good example is the Azure Redis Cache, which uses Redis engine underneath. And another example is Azure Search, which uses the Elasticsearch behind the scenes. And now, as Docker is taking over the industry, Azure has this deep integration with Docker. We are not just talking about running the Docker engine on the virtual machine. I mean, everybody can do it. But for Microsoft, we have a really deep Docker integration. If you see the keynote from Wednesday, we announced the Windows containers. And the way we did the Windows container was really unique. Basically, Windows container integrated with Docker at a very low level, at a very low API level, which means all the existing Docker tools and Docker APIs you're familiar with, you can use the same tool to manage both Linux and Windows containers. Actually, we'll show a brief demo right after this. And of course, as part of the openness, Microsoft has been working with all kinds of standardization bodies. Actually, we are working with over 150 standardization bodies and over 400 workshops around the world to establish, adopt, and advocate for industrial standards. And two of the examples you will see is the AMQP support and OPC support in one of our scenarios. And last but not least, the success of open source is based on the strong community. So that's why Azure has this template, which we'll deep dive in a moment. And we have things like a marketplace and VM Depot, which contains hundreds and thousands of templates and help you to bootstrap your workload on Azure and get going really quickly. I think we'll talk about VM Depot in this session as well.
I'll cover VM Depot.
So this really gives us a really vibrant and rich open source community on Azure. If you love some framework or love some tools, chances are you'll find it on Azure. And in terms of development, you can use your own familiar tools, languages, databases. You can develop on your familiar devices and integration with a lot of open source solutions. I think our CEO put it in the best way. We have really made sure that Azure is a very open platform. It's not just about .NET and Windows. We have the most open infrastructure. We want to thrive in this heterogeneous world when it comes to the public cloud. So with that, like I said, we have many demos. I want to go through all the demos as possible. So I will show for the first set of demo, I will show two demos. One is the Windows container on Docker. I know there was some demos shown in the keynote, but this one will be different. So in this one, we are going to deploy a Minecraft server, which is Java-based, on the Windows container, and we'll see how that works. And the second scenario I'm going to show is how to deploy a MongoDB across region, actually across continent replica using Azure. This is one of our big e-commerce partners. And the first question they asked when they tried to adopt Azure was if we can get MongoDB to work with cross-region replicas. So let's jump into the demos. So the first one we are going to show is Docker. This is the Docker client for Windows. You can. This is just regular Windows application. You can operate on your Docker containers remotely. So let's say I'm creating a new Windows container. What do I have is the Windows Server Core image. This is like a slimmed down Windows. Contains all the Windows system libraries. And now I'm actually in the container now. This is not on my local machine anymore. This is the Windows container running on my machine. So I can do dir sys info basic commands like help. This is a fully functional Windows. But now I want to do something really terrible to this box. I want to say reg delete software. So I'm deleting a whole chunk of registries. You know this will be really, really bad to the Windows box. But I'm going to do this anyway. It will take a while because it's taking out a lot of stuff. And now basically my box is broken. If I do something basic like help, I cannot do this anymore. System info, yes, broken. How about RG itself? Okay, broken as well. So basically there's nothing much I can do with this box. But I can exit and just nothing happened. This container is gone. When I launch the next time, I will get a fresh container. Everything still works. But that's less interesting. Let's do some more interesting stuff. I have a container named Minecraft. IT Minecraft server, CMD. So this is the image I built. If you are familiar with Docker, all you need to do is to define a Docker file, define the commands and files you want to include in this image, and you build it, then you can run it. So now I'm in this Minecraft container. If I do an ipconfig, I can get these IP addresses. But instead of using a command line, I will use remote desktop to connect to this guy and see what's on it. Let's see, 10.5.40.187. Administrator. Password. So now I'm remote desktop into my container. It just feel like a Windows box. Let's see if I go to the, let me make this font a little bigger. Okay. You can see I have some file preloaded on this. I have the Java runtime already installed in my Docker file. And I have this Minecraft server .1.4 version I'm about to launch. But before I do that, I want to show you some interactions you can do between the Docker host and the Docker container itself. So I'm going to the host machine that is hosting the container. This is the host. And if I open disk manager, you can actually, on here, I have a container volume here. That's actually mapped to my container system drive. But here on the host, I can assign a different drive letter to it. Let's say I give it D drive. Then I can just use this as a regular drive. This is a D. I can there. I can say, hello. Hello text. Okay, I created a file. And what I have also under my host computer, I have a different server configuration for Minecraft I want to use. This is the server.properties. I'm just going to copy this file to D drive. And now, if I go back to my container, I have to keep track of where I am. So I'm back to my container. First, let's look for that file. You can see the hello.txt. If I type it, hello.txt. Oops. Is cat? No, it's tab. I have to switch between the Linux and the Windows commands. But anyway, so I have this configuration file transferred over. Now I'm ready to launch Minecraft server. Minecraft server. As I said, this is a Java application. It depends on Java runtime, but we can totally do that. It's installed by the Docker file. This will take a while. Now I have a functional Minecraft server. And what's the IP address of this guy? I forgot. Now let's launch a Minecraft client just to see if it works. So I have this Minecraft client login. Oops. Let me minimize this. Okay. I have to find the IP address. So I will use multiplayer. I'm going to do a direct connect. There's a different IP this time, of course. This is a 10.5.40.187. And join the server. And here I'm running Minecraft in a Windows container on my local box. And just to show I can actually interact with this, I'm going back to my Minecraft server. I'm going to change myself administrator. Oh. OP, oops. It's a little slow today. OP, hi, pig person. Actually, I have a little story to tell about this unfortunate user ID, the high pig person she. Basically, when I was trying to purchase Minecraft, I had some problem with my credit card. So I asked my sister in Belgium to pay the bill for me. And just rest assured, doesn't matter how old you are, your older sister will still pull all kinds of pranks on you. So she named me the pig person. And unfortunately, this name cannot be changed. So I'm the pig person ever since. But it's okay, I don't mind. So now I promoted myself as an administrator. If I do this, I can do some advanced stuff like weather, I make it rain. Now it's raining. So this is a real functional Minecraft server on the Windows container. So that's the first demo. I think that's a good demo for Friday, right? Okay. Now let's talk about more. Am I over time already? Okay. Now let's talk about more serious stuff. This is a huge jump from Minecraft to MongoDB. Okay. So as I said, when we spoke to this customer, the first question, because they are a huge MongoDB user, the first question they ask is that, can you run the cross-continent replica site on Azure? And we said, sure, let's do it. So this is the architecture we came up. Basically, we set up 2 virtual networks, one in West US, one in West Europe. And they are connected through a service called virtual network to virtual network connection. We have this gateway that you can bridge different virtual networks. And if you didn't notice, we just announced a new tier of this gateway that provides a much more throughput than before. And you can integrate with ExpressRoute, where you can use a dedicated connection as well. So the throughput is not a problem. The performance was great. We did a performance test. The latency is like 100 milliseconds or something like that. So in this setting, we determined our US West will be the primary site. We have a primary server and a secondary server in this, but we will use the West Europe as a backup. So the backup is a member server is set to secondary, and the priority of it is set to 0, so that it is never elected as the primary. And the reason we do this is that because all the workloads is actually hosted in US West. We want a minimum latency, but we want this failover to West Europe if something really bad happened. So to do this, what we did, we used a couple of things in combination. We used the Azure command line tools. We used Azure extensions and custom scripts. Of course, in this project, we did everything kind of manually. We wrote all the scripts and drive all the deployment process. Mahesh, which in a moment he will introduce the Azure template, which is a much declarative way for you to capture your whole infrastructure. But for this particular project, what we did is that we read a couple of scripts. First, we have a master script that you run on your client. This script will drive all the provisioning process. And we have an on-machine script. This machine will be executed on all the member servers. We upload this script into a blob storage. Then what the master script will do, it will create the virtual network. It will provision the virtual machines. Then on the virtual machines, it will enable custom script extension. This is one of the virtual machine extensions we support. Just in case you don't know, the virtual machine extension is a small program that you can install on your new or existing virtual machines that customize your virtual machine in different ways. For instance, if you want antivirus environment, if you want Chef or Puppet integration, or in this case, if you run a custom script, you can install different extensions, and they will take care of the business for you. So in this case, we are setting up the primaries and secondaries, and they all have custom script extensions enabled. And once these machines are launched, they will go to the designated storage account, download the script, and run the script locally. So this script will download MongoDB and configure some host files and join all the members into the replica site. So for this, I'm going to give you another demo. I'm going to jump on my Ubuntu box. So first, I'm going to show you the master script. I have to create a different version because we need to mask the customer name. But if some name leaked, I apologize. So in this script, actually, we are creating a 5-machine cluster. So we create 3 in West US and 2 in Europe. And so we are enabling endpoints. Usually, this is not what you want to do for actual deployment. You want to keep your database private behind the virtual network. But for the demonstration purpose, we open up the endpoint so we can access those machines from public. And then here's the complex part. It looks a little scary, but in such a way, what it does is specifying which storage account and which storage URL you need to download that script. Then you specify what the commands to be executed on the machine. In this case, I'm just calling the on-machine script. So let me quit that. And the on-machine script, let me show you this, MongoDB. And you can see once it's on the script, on the machine, it just do the regular shell script stuff. It downloads MongoDB, install it, it defines some host names, and just start a new cluster. And that's the result. Let me connect to one of this. I think I can, what's the master? Mongo1, cloudapp.net. You can see now I'm connected to the primary. If I DB users, find, I have 3 users here. And if I open another shell script, console, I'm going to connect to a secondary, if I can type in my password right. I'm going to connect to a secondary in West Europe. Let's say Mongo, let's say 5 this time. You can see I'm on the secondary. I'll say I will do queries from my slave. And if I'm back on primary, you can see the status of my replica site. The first one, the Mongo1, that's the primary in West US, and we have 2 secondaries in West US. And you can see the ping time between them is barely minimum, it's 1 millisecond. And the other 2, Mongo4 and Mongo5, they're in West Europe. The ping time is a little bigger, but not a big deal. So now let me just prove the point, and let me insert a new user. First, I think we have James now. Last, Baker. Oh, James, sorry. You didn't say anything. Okay, and I give you a score, like 200. DB users, insert this user. So I'm inserting this through the primary. And if I switch to secondary, and you can see James is right here. So this is a cross-continent replica almost in near time that we set up in 2 shell scripts. So that's this part of the demo. So the next topic, like I mentioned, I hope I proved some points that we really love open source. We are making our efforts to embrace the open source community. But using open source has its own challenges, right? Some of the open source projects are not as stable. Sometimes it's just one person doing the open source project, and then one day he lost interest. And there are some other things. If you have this wonderful technology, you still need to manage all the resources that support this framework. For instance, if you want to run maybe Storm, you need to provision all the virtual machines and organize them together. So this is why Azure template is such an important technology. It allows you to capture your entire infrastructure as code. This includes not only our first-party services, but also the open source services. And to speak to that, I will invite the expert, Mahesh, to talk to you about this part.
Cool. Thanks, Haishi. All right. We are about half the time, so I'm just going to kind of run through. All right. I think so I'm Mahesh. What I'm going to talk about is what we announced at Build this time around. We announced support for the templating capability for compute, network, and storage resources. What this means is now you can go architect whatever Hashi showed as 5, 10 different scripts in a single script and just deploy it in a single click. So we actually have MongoDB high availability cluster template available already on Azure.com, so you should be able to go find it. And in a single click, you should be able to go deploy a MongoDB high available cluster without having to do a lot of the work. We just did it. So that's the power of what we're announcing with the build announcement. Now, before I go deep dive, I want to just kind of introduce, just talk a little bit about Azure, some of the key parts about what we did with Azure, right? We wanted to make sure that hit a few key aspects about being a truly scalable cloud. We focus a lot on hyperscale. If you are going to be around, for the next session, I'm going to talk and showcase some, and I think Hashi is going to probably do a demo on scalability as well. We've truly gone hyperscale. There are a lot of services on Azure, and I think we're going to introduce HT Insight and other services that talks about the scalability on the cloud. We are truly enterprise grade, and I think we talked a lot about the certifications. We have a lot of the compliances to make sure that any apps that that customers need can be met with the enterprise grade capability that we have. We are also hybrid. When I say hybrid, it crosses multiple bridges. Hybrid across the sample that we talked about, where you can connect multiple regions, is hybrid. We also work a lot on making hybrid connectivity possible between on-premises and Azure as well. So when I say hybrid, you can actually connect your on-premises environment to Azure. And with this Azure template capability that we just announced, we also made an announcement about how the template file that you guys deployed or are architected can actually work with on-premise too. So a single template file that you actually go model to deploy MongoDB will not just work on Azure. Going forward, you can take the same template file, go deploy it against an on-premise environment, which is managed by Azure Pack. So the single unified Azure stack is what you're getting. So you're no more in the business of just, hey, do something for Azure, go do something else for on-premises, and then just write a bunch of scripts to connect them. It's all about just a single file that allows you to manage an app between on-premises and Azure. So that's another key announcement that we made. All right. And I think just being an enterprise-grade cloud, there's a lot of things that we focus on, making sure at an infrastructure layer we have security. Then that at a VM level, how we ensure security, we make sure that there is we protect your VMs against DOS attacks. We make sure that we provide the application level security controls. Like when I say application level security controls, thinking about integration with giving you extensions that allows you to install anti-malware inside your VMs, giving you the platform capabilities for protecting your endpoints on the cloud, giving the integration with Azure Key Vault to make sure that you get first-class capability where you can store your keys in Azure Key Vault, but then you can certificates or keys in your Azure Key Vault, but then when you deploy these VMs, you can fetch them on the fly. So we provide first-class security control and capabilities with the integration of virtual machines and Azure Key Vault. So this is truly an enterprise-grade cloud with at security being provided at every layer, starting from physical to the infrastructure layer, down to the platform layer at the networking level, and then inside the VM as well. So inside the VM, you get like anti-malware and security extensions and the integration with Key Vault. Okay, so the next 5 minutes, I'm going to talk briefly about what we announced. So I need to introduce a couple of concepts to you guys. The first concept that I'm going to introduce is the concept of resource groups. Resource group is, think of them as a container, a software container, which holds your application together. It could be an application, or it could be a set of resources that have identical lifecycle. So in the case of the example that Hashi pointed out for MongoDB, you could think of placing your entire MongoDB application in an entire resource group. The reason why we place the resource group together is it gives you the controls to manage that entity as a whole. A good example is, let's say you're doing some development and testing, and you're like, hey, I'm spinning up a 3-node MongoDB cluster, I wanted to do some perf tests, and then I'm done. So if you want to go clean that environment up, you'd have to go delete VM1, delete VM2, delete VM3, no more. You can actually just delete the resource group, forget about this, and then actually have an entire control of resource group as an entity to manage your application. The other aspect about resource groups is we also have the support for tagging. Tagging is very powerful. When you tag a resource, it's not just for querying and searching for like, hey, app equal to MongoDB. What it does is these tags propagate through the system and actually show up in your bill at the end of the month. So imagine a case where you're sharing a subscription with multiple users. You can actually have each user tag their own entities, and at the end of the month, you can actually build the CSV file that comes out at the end of the month. You can actually pivot chart and look at, oh, how much did I spend for MongoDB? How much did I spend for my web tier? How much did my engineering department spend? How much did my IT department spend? You can actually go do all of the configuration by using this tagging capability. And the reason why resource groups helps is imagine a case where you're building a scalable front end where you have 200 VMs. It's impossible to go manage and configure every individual VM. So the resource group is a container where you can go tag that and say, this tag is just for the web tier, and it propagates, and all the 200 VMs at the end of the month, you can actually get the cogs completely meshed and seen as a single entity. So it's very helpful from that. The third thing around that is a role-based access control. So role-based access control is, anytime when you provision a subscription in Azure, you get an Active Directory tenant as part of it. So you can go add users or groups as part of the Active Directory tenant. Let's say you have 3 users. One guy is a SQL admin or a database admin. The other is a network admin, and there is an overall admin. So you can actually have different resource groups carry the database, another resource group that carries the networking configuration, and you can have the network admin only be the person responsible for toggling or changing the network properties, and the SQL admin or the database admin doesn't have privileges to go change that. So he only acts as a reader access. So you can completely slice and dice and provide the right amount of security across the different resource group by architecting your application appropriately. And a resource group spans multiple regions. So in this case of the MongoDB sample, you could have a resource group where you can actually have 3 VMs sitting in West US and 2 VMs sitting in West Europe, but you manage the whole entity as an application where you just look at it from a single resource group. So you can do that. Okay, templates. So I'm not sure if we do a template later, but if you are around, do stick around for the next session. We'll go deep dive into templates. But at a high level, templates are nothing but think of them as a model file that defines the configuration of your deployment, including the infrastructure. And it also contains the configuration of the apps that you want to configure inside the VM. It's not just, OK, I need 5 VMs. That's not it. You can actually say, I have to run script 1 to go configure MongoDB first, and then I have to run script 2 to actually join to the server or something like that. So you can actually have the entire app defined in a single template file or multiple template files and actually link them together. The key part about the templates, it's idempotent. So when you actually say, let's say you deployed on day 0 with 2 VMs, and you come back later and say, I want to add 2 more VMs to it, you can use the same template file, just change some properties and say, go deploy it again. We will detect that it's only the first 2 VMs are already up and running. So we spin up the next 2 VMs. So we have that power. It simplifies orchestration. Orchestration is not done just at the infrastructure layer. Orchestration can be done even for the scripts. So you can actually have 2 VMs and say, script 2 on VM 2 should not run until script 1 on VM 1 is done. So you're not just orchestrating saying, wait for infrastructure to be spun up. You're also defining the dependencies between the script files that are running inside the box. So you have the power of going and deploying an entire app without having to worry about redoing the work again and again. Simplifies rollback a little bit, because if you are doing some dev and test, you're setting up the environment, you don't have to worry about, oh, where did it get stuck? You can just go delete that entire resource group, use the template again, start a new one. So it gives you the flexibility of dev and test in a very simple fashion. And it supports cross-resource configuration support. So for applications that involve, hey, I want to go use Service Bus, or I want to actually use Azure websites as my front end, but then I want to configure MongoDB at the back end. So for applications around where you want to configure cross resources on Azure, this template file can carry both. It's not just tied to compute, network, and storage. It is for all other resource types that exist on Azure that is under Azure Resource Manager. So you can package them into a single file and deploy it as an application. We view the Azure template files as source files that are checked in. It's not stored on the cloud. It's something that you can check into your source control, can be on Git. We've announced a lot of template support on Git as well, so you should go take a look at them. And the parameterization part of the templates makes it very repeatable. Here's a quick screenshot of the template location. But the key points here are really around complexity made simple. You don't have to worry about handling 10 different files. You can just have a single file that deploys the entire app. We are blending the, thinking about apps more than just infrastructure, so you can actually blend your IaaS and PaaS applications together and get your app that you desire. We've focused a lot on scalability, so the ability to spin up VMs on Azure is really, really fast, so it's going to be scalable deployments. We've provided language capabilities in the template where you can easily scale up and down, so you can actually say, hey, I want to go spin up 7-node Cassandra cluster, for example, and we will detect that and just be able to spin up 7 nodes. And then the integration with role-based access control on tags makes it very powerful for you to go build an app and actually maintain and manage it going forward. With that, I'm going to go hand it back to Haishi to do the DCOS demo.
Thank you. I do apologize. I used too much time at the beginning. So I think we'll skip the next demo. This is a DCOS demo. Essentially, this is a repeat of Mark Resinovich's demo on the first day. So I think you can just watch the video there. Let's jump in the sample scenarios. We have 3 big sample scenarios. I hope we can still cover those magically somehow. So the first one is about the LAMP stack. And for that, I will invite Brian to talk about that.
Thanks. So there's a couple of things I want to show you today, actually. Actually, I'm just going to jump into the demo, I think, because we don't have a lot of time to go through the slides. 5. Yeah, we're on. OK. So what I want to show you today is, so the easiest thing to show you with LAMP stack is WordPress. And I've got a fairly complicated configuration that I put together. I've actually, here's the WordPress site. This is the virtual machine on cloudapp.net. And basically, it's just a template where it's a question and answer template. You can go in and ask a question and put an answer and things like that. Then we have an Azure website, the exact same thing. If I put a new post in here, it's going to update on both sites, on the Azure website and on the virtual machine, because what I've done is I've actually pointed both of them at a MySQL database. So behind the scenes, actually, let me just skip over to that. Where is that diagram? I'm just going to skip through all these. Uh-oh. I guess we missed the diagram. OK, version control issues. That's OK. I can cover that. So basically what I've got here, what you're looking at, let's put it back in 5 then. I thought I was going to save time. That didn't work. So basically what you've got here when I did this is I split out the MySQL database into a separate VM. And I point the VM running WordPress and the web app running WordPress at that MySQL database on a separate VM. Now, how you actually set that up, there's a couple ways to do it. In the way I did it is basically when you go into WordPress, I'll use Web Matrix today. It's pretty easy. You can go in, you can get the SSH, FTP, and you can just go in and actually edit these. I'm just going to edit the live site. You ever seen that graphic? Who's seen that graphic? I don't usually write code, but when I do, it's in production. Have you seen that thing? That's pretty good. Let me show you that, actually. I should have had this ready. Yeah, it's pretty good. Whoops, nope, not that one. Oh, well, that's not a very good one. But I don't always test my code, but when I do, it's in production. So I like that little graphic. Anyway, so we can go into Web Matrix. We can actually change the file, which is in WP config. I've got a sample file here I can show you. And in that sample file, basically, you just edit these settings to point it at the right database, the password, the username, things like that. So it's pretty simple. Now, how did I actually get the web app going? There's a couple ways to do that. You can go through the gallery here. You just say new marketplace web app from gallery. And we've got WordPress and a couple other things as well Down here, there's a regular WordPress and a Japanese WordPress. You fire up WordPress, and you put in some parameters here, and it creates that. The way I set up the VM was through VM Depot. How many people have heard of VM Depot? Okay, a couple of you, good. So something new we're going to cover today. VM Depot is a repository of virtual machines. And inside that repository of virtual machine, there's about 700 of them. They're all Linux, they're all free, and they're all open source. So the way I did this actually is I chose this actual item here. You can go through here. It's vmdepot.msopentech.com is the URL. You can click on deployment script. You make the lawyers happy. You pick a region, Brazil South. This gives you a CLI. How many people are familiar with the CLI, the command line interface for Azure? Okay, so there's a command line interface for Azure. You can download it. It's node-based, and you can actually use this script, cut and paste it, put some parameters in there that are specific to your subscription and the server you want to put it on and things like that, and it will actually deploy that out to Azure. It's a full WordPress stack with, it's got Apache, it's got MySQL, it's got WordPress, and it's got PHP, all configured together and ready to run. It only takes a few minutes. It takes about 5 minutes to fire it up, and you can actually run that. If you don't even want to learn how to use the scripts in CLI, you can go into the new portal, and hopefully we haven't timed out here. If I go to the marketplace, good. Press. So I can choose one of these WordPress templates. These are the actual gallery templates. Everything's kind of mixed together in the new portal. But you can see down here, there's a couple of different WordPress virtual machines. If I click on virtual machines, it includes all the WordPress images that I just showed you on VM Depot. And with these, you can literally just click on one of them. Let's do a WordPress 4.2. Where is that one? Oh, let's do something even more exotic here. WordPress on Nginx with Percona MySQL. It's one of the options you can get from there. You say create, and it gives you a bunch of settings. You can set up a resource group. You can set up all kinds of information there. You have to pre-configure endpoints, things like that. When you click on create, it's actually going to go ahead and create that VM for you as well. So it's even easier. You don't even need to learn the CLI or the scripts or anything like that. Through the new portal, you can do it that way. So as I showed you, what I did after that is I went in and I went through Web Matrix to change the image to point at a database that I created. Oh, and actually, how did I create the database infrastructure? I didn't actually create it from scratch. I used another VM Depot image. It's just a lamp stack image. And the lamp stack image gives you something that's kind of handy for, it actually gives you a bunch of features that you can use, like PHP MyBB and a few other things for managing a lamp stack. And then I only used the MySQL part of it. I copied using MySQL dump, which is a tool for MySQL. I took that to copy the actual database from my WordPress instance on the VM to the lamp stack instance VM, and then pointed everything to it. To point from the VM that runs WordPress to the VM that runs MySQL, I just use WinSCP. You just go in there. Instead of PuTTY, you can go through the command line. You can do all kinds of things, but I just go through WinSCP, and you go into wp-config.php here. I won't open it up because it has all the parameters and passwords and things in it. Just basically edit it here and save it again. Once again, I did it in production, which probably isn't the way to do it if you're using a real site, but that was the easiest way to do it for here. So that, in a nutshell, is the WordPress part of the demo I wanted to show you. All of the stuff that we have here, as I mentioned, I used all VM Depot images, all Linux running Ubuntu, WordPress, MySQL, and then I scaled out the image from the, I actually used the web app, which is a little more scalable. Now, there's two things you can do for scaling the VMs as well. Who here knows the difference between traffic manager and load balancer? Couple of people? Okay, so basically we have two features for scaling VMs. We have traffic manager and we have load balancer. Traffic manager works at the DNS level, load balancer works at the network level. And why is that an important difference? You can use traffic manager to point to your WordPress VMs, as many as you want, and it has a few other features that a typical load balancer that just sprays connections across a pool of resources doesn't have. You can do things like round robin. You can weight things to a certain location. You can actually weight things to a certain location based on the source IP address. So if someone's coming in from Europe or something, you can actually trigger them to go to a resource that's local in Europe or Asia, et cetera, et cetera. For the load balancer, you can use that on the back end on your MySQL database to actually spread the load across multiple VMs running MySQL. So that's sort of the difference between traffic manager and load balancer. Now, the other thing I want to show you, switching gears a little bit here, I want to show you Java. How many people work with Java here? Just a couple, okay, all right. So we've got some tools that we've created for helping you deploy things on Java. I'm in Eclipse now. This is a tool that we actually built. Let me show you what it does. It's a sample Java application that you can use. Let's see. And basically, the sample Java application is a chat application. It looks like Facebook or Snapchat or something like that. You can post comments. You can post pictures and video. And you can share it with your friends. Everything expires after a certain period of time. And it all runs on a Tomcat server on Azure and points to all the services that we have in the Java SDK. So we have this Java Azure SDK, which has a lot of services that connect to Blob, Table, Media, Service Bus, et cetera, et cetera. I've used all the services in this app. If you're going to Ignite, by the way, if anyone's going to Ignite, I'm going to be showing that off a little more detail. But this is an app that we built that just shows off basically every Java SDK service that we have out there. So in Eclipse, I've got the application here. And what I can do is I can actually create, it's called AzChat. So I can actually create a new deployment project from this. If I click a new deployment project, call it anything I want. In here, I can choose the JDK I want to use. I can deploy it from local. I can also deploy it from a third-party JDK out on the web. I can actually use a blob storage account to deploy the JDK. Same for the app server. I can actually use Tomcat. Let's see, I'll use Tomcat 8 today. And it knows which Tomcat I'm using, but these are all the different app servers that you have to use with your application. You can actually deploy a third-party server as well. We've got basically just Tomcat at the moment. You can deploy from a custom download again. The reason why you want to deploy all these options is you can actually make the Java package when you deploy it smaller. And then we have some other settings that you could use. Here you can have the application. We have session affinity, caching, and remote debugging. These are all documented, so I'm going to skip over these in the interest of time. Basically, once you've done with this, you can finish it, and you can actually create worker roles. Whoops. It's taking a minute to close. There we go. Where's my project? So you can actually create multiple worker roles. So in this case, we've got role 1, because that's the default. You can create multiple worker roles with multiple sizes, and when you want to deploy this to Azure, it's automatically going to deploy all these things for you. This runs on Eclipse on top of Mac, Linux, and Windows. If you use Windows, you can test locally in emulation mode before you actually deploy out to Azure. And once you deploy out to Azure with just one button, so when you click this and I say publish to Azure Cloud right there, it's actually going to go ahead and publish this out to a cloud service in my subscription. and let me know when it's all done. One of the new features we have is it actually generates an Ant script. How many people are familiar with Apache Ant? There's a couple? Okay. So I won't go through the details, but basically, by the way, this is Visual Studio Code running in XML. It's just, Ant is XML-based Apache project that allows you to repeatably deploy things out to the cloud or anywhere else. It's basically a project manager, a package manager as well for Java. And one of the nice things about that is you can take this Ant script and put it anywhere you want that Ant runs. You don't have to have Eclipse or our plugin running, and it'll do it from there. It'll actually run. And by the way, Visual Studio Code, pretty good XML editor. People don't talk about that, but it is pretty cool. It has a lot of syntax and a lot of settings there. IntelliJ, I was just going to show you this real quick. Basically, it's exactly the same thing, so I won't waste a lot of time on that. This is JetBrains' IntelliJ product. We also have a similar plugin for IntelliJ, for Android Studio, which is based on IntelliJ, for those of you who are interested in Java development and deployment. And all of the things I just showed you are open source on GitHub. And the MS OpenText tools for IntelliJ is here. The Windows Azure Toolkit for Eclipse with Java is here as well. And I'll hand it off. Who's speaking next?
Yeah,
okay.
Thank you.
Yeah.
I think we are only 8 minutes away. We still have 2 scenarios. Unfortunately, I think we'll skip the last one, which is the Internet of Things, but we can talk afterwards. But I think I will leave the rest of the time for James to talk about big data and the work we've done with Emerson. Let's go back to PowerPoint. I will set you up, and I will get out of your way.
Okay, cool. So, let's sort of try and bring this home today. We're sort of going to talk about big data. Big data is an area that sort of the open source community has absolutely thrived in. There's many projects that are sort of based around open source that target the processing of large-scale data in generally a distributed fashion. Some of the characteristics we see in some of these projects sort of can be presented here. And again, another characteristic is that there's many components can fit into these various phases of an end-to-end project. And you can see a variety of offerings there, both sort of Azure has developed many first-party services that go and fit into these phases, but at the same time, there's many open source projects that can also fit into that. And sometimes it's desirable to mix and match. You might want first-party services for data ingestion, but third-party or open source projects to do some of the transformation or processing on it. And so, we're sort of trying to build up the platform to provide as much opportunity to do that as possible to give you the maximum flexibility. Also in sort of big data, it's a big sort of word. There's many horizontal sort of scenarios that appear in it. Today we're sort of going to drill into an IoT-based scenario, but there's many more that sort of fit in there. Some of them are mostly horizontal, some of them are vertical, but it's not a one-size-fits-all, and so that's where the flexibility and the openness really comes into play. So today I want to talk about a project we collaborated with our good friends at Emerson Electric. They're in the business of, they're in a very large business, but one of the projects that they wanted to work on was about sort of instrumenting and gaining telemetry and insights and monitoring of refineries, large-scale, generally remote refineries, sort of harsh environments in which you could sort of have all this computing work, but they needed to do, and they wanted to be able to leverage things like predictive analytics to determine failures beforehand. They wanted to be able to look at historical data to say, okay, how the performance of this refinery had been going over the last month, over the last quarter. But they also then needed to be able to have live dashboards as well, so that operators sitting in the rooms in the refineries can see how the process flow is going, what the quality levels are like, and also see alerts getting fired off. If a valve's failed, they need to go and take some action on that, and so they need that information as quickly as possible so they can go and avert disaster. The system we worked out with the Emerson folks, you can sort of see the system architecture diagram here. It's sort of fairly complex, but just basically there's a sort of a data ingestion point. There, as I say, many instruments out in the refinery that are sort of flowing their information out through a series of field gateways. Eventually it all funnels up into a TCP gateway that's sitting up in Azure. They then need some reference data that flows across, so sort of metadata about those instruments, but as well as the live telemetry itself. And so that sort of forks at that point. You can see the instrument data goes up into the top and gets processed through Kafka and Storm, and then sort of comes down through HBase. But also you can see off and to the right where number 5 is listed there. We've got the ability to reach out into the Azure Machine Learning service, leveraging a sort of a operationalized or published web service from a trained model. This model is being continuously trained as the data flows through, but then they can do sort of scoring of aggregated time series data to do that predictive analytics, so that they can see if they can sort of predictively determine whether the quality is going to fall off and they can take corrective action on that, or they're about to hit some failures and take action before the failure actually occurs and minimize costs on the refinery. Then the data obviously needs to flow out, and I talked about before about the ability to do historical analysis as well. And so then there's a whole pile of reporting information that's needed, and so the data flows out of the HD Insight clusters and into sort of stable storage, and we can leverage a bunch of reporting tools that show that information as well. So the one area I do want to talk about, as I mentioned before about the ability to mix and match, Emerson, one of the requirements they had is that they needed to be able to run this system both on-premise. Most of their refinery customers sort of want to run this in the data center in the refinery, but then they increasingly want to take advantage of cloud work, and many customers are interested in moving their workloads across to the cloud. One, just to reduce the infrastructure cost in the refinery, but two, take some of the advantage of cloud-based machine learning, cloud-based reporting tools, and sort of just generally sort of contemporarily upgrade the entire workload. As Emerson wanted to be able to manage this transition, they sort of needed to achieve a certain degree of symmetry between what the on-premise solution looked like and what the cloud solution looked like, and yet not sort of take a lowest common denominator. And so they wanted to be able to take advantage of some of the cloud services that are available and still achieve essentially the same system. And so they looked at where you see in this diagram, and sort of a large chunk of it's all contained within a Hadoop cluster. So obviously the on-premise, they can run a Hadoop distro of their choice, roll that in there, run those standard Hadoop components in there, but they sort of have to do all of the management of that. Either the operator on site or the Emerson sort of installer has to sort of go and set that up, keep it running, keep it managed. And so when they looked at the cloud solution, they sort of said, okay, well, what's a more sort of automated, managed way? And they looked at the HD Insight service that's up in Azure, which is just a management wrapper around the open source Hadoop project. So there's no sort of super magic in it. It is just Apache Hadoop through actually the Hortonworks distribution of Hadoop. But it provides management. So if VMs are failing, the system automatically picks them up. There's monitoring built in. A lot of the things happen automatically for you. And that was a great sort of factor in the way that Emerson considered the solution. In that sort of HD Insight solution, there are a bunch of things. There's HBase already installed. There's Storm already installed. But for this particular solution, what they needed is that message ingestion service, Kafka. And so Kafka is an open source sub-project of Apache Hadoop that provides distributed message ingestion and message distribution. And the HD Insight service doesn't give the ability to run that today. And so we sort of worked with them and said, okay, well, how do we, into that existing HD Insight cluster, how do we get you that Kafka service so we can run that diagram end to end? So today I just want to quickly show you what that looked like. If that one flicks across, perfect. Let's get rid of some of Harshy's stuff. Yeah. All right. Okay. We're really running out of time. Sorry about that, folks. I can't even skip forward this quickly. Well, the point I wanted to land here is that there's a custom script. We wrote some PowerShell scripts that downloaded the Kafka binaries, installed them onto the HD Insight cluster, customized them, and we were able to go and run the Kafka topics, connect them up to Storm topologies that we were able to also manage, and then the system ran through. So unfortunately, I was going to take you through all that, but we're not going to be able to do that now. So let's finish up, Harshik.
All right. I do apologize we didn't want through all the content. When I was planning about this, I felt there was plenty of time. But anyway, let's wrap this up. The scenario we didn't get a chance to show was the OPC Foundation, which is a standardization body that we did several projects with them to allow them to iterate between the industrial data. But with that, we are out of time. Thank you all for coming, and thanks to all the great speakers I have today. And I hope you enjoy the rest of the build. Thank you.